Welcome, Hornets, and thank you for joining me today. Today I'm going to be talking about and reviewing expanding and condensing logarithmic functions. So we're going to be taking a look at a worksheet that I put in to the Google Classroom as extra practice. So for those of you who are not students of mine, um, I'll go ahead and I'm going to put this up for you to see it. And if you wish, you can take a screenshot of the first part first. Then I recommend you take a screenshot of the second half. And having taken screenshots, be aware you can go ahead and try to do this on your own now, and then come back to the video to identify whether you were successful or not. For those of you who are not sure, just go ahead and follow along with me as I go through it, and as you gain your confidence, pause the video and try to do problems on your own as you can. So you'll notice that I have a choice whenever I have an exponent that's outside. We do, for example, have our laws of powers, which tell us that we can distribute that exponent. This would then give us a log base 6, and we would have this x to the fifth, and then y to the 5 times 5, which is 25. From that, we could then expand it. Option B is to bring the power into the front using our third property first, and then at the end we'll distribute. So in this problem, we would have log base 6 of x to the fifth plus log base 6 of y to the 25th, and the power would then move in front, giving us 5 log base 6 of x plus 25 log base 6 of y. And that would be our answer if we did it that way. This way, we would be distributing at the end as opposed to distributing at the beginning. And we would then have 5 log base 6 of x plus 5 log base 6 of y, and then distribute to get 5 log base 6 of x plus 25 log base 6 of y. Now, whether you decide to distribute at the beginning or the end, it will have to be put in at some point in time. Let's go ahead and go to number 2. Log base 3 of x times y times z to the fifth power. This is going to use our first and third property. So for this, we're going to be taking our log base 3 of x plus log base 3 of y plus power moving in front, log base 3 of z. Now remember, if we had a denominator, for example, let me just go ahead and make a problem up on the fly and take log base 3 of xy divided by z to the fifth. Because I now have a minus, the problem will end up having a minus as opposed to a sum. Notice the numerator still has the product up top. They will still be a sum, but now we have a minus 5 y to the log base 3, of z. Now the reason for that is because we can always rewrite this power, and we can rewrite it as log base 3 of x times y times z to the minus fifth power. And now I can have a plus with a negative 5, and when I have a plus with a negative, the negative can always move in its place. All right, let's take a look at our third problem. Log base 10 of x cubed y to the fifth. When we expand, we're going to have 3 log base 10 of x plus 5 log base 10 of y. Now we can make these problems more difficult by simply putting in some power of the base. For example, let's take log base 2, and I'm going to put an 8x squared y cubed. Well, this is really 2 to the third power, so I would have log base 3 log base 2 of 2 plus 2 log base 2 of x plus 3 log base 2 of y. But we have a rule that says log base 2 of 2 is 1, and it would give us 3 plus 2 log base 2 of x plus 3 log base 2 of y. So just be aware, we could make this more difficult by starting to use values as opposed to variables. Let's take a look at the next group where we are going to condense into a single logarithm. And let's see, we have log base 3 of 11 plus 2 log base 3 of 12 plus 5 log base 3 of 7. So in this problem, we're going to condense by moving all of our powers. So I have log base 3, this is 11, times 12 to the second power, times 7 to the fifth power. Now, if we're not trying to get a whole number, we can go ahead and leave it like this. We could break it down into prime factorization so that we would have a 3 squared, and that would be 11 times 3 squared times 2 to the squared is the fourth, times 7 to the fifth. Now, all I did was break down that 12 into its prime factorization. And you'll notice it's made it a little bit more complicated. Now, if we were allowed to use a calculator, we could always multiply 7 to the fifth and so forth to see what our answer would be. But this should be enough. Let's go ahead and move on. We're now going to go to the next problem that said 5 log base 9 of 2 plus 5 log base 9 of 3 plus 20 log base 9 of 7. Once again, we're using those properties that I've already shown you in the notes, where we're taking our values and condensing. Let's just review those 3 properties one more time for the sake of argument. If we have let's do log base 10 of m times n, they expand into log base m plus log base n. They condense backward. Fractions represent minus, so m divided by n is going to be log base m minus log base n. And then when we have powers outside, let's do m to the n power. This then would be n times log base 10 of m. Now, going backward is the same idea. So if I have this going on multiple times, I'm going to use it multiple times. Here we go. Log base 9 of 2 to the fifth power plus log base 9 of 3 to the fifth power plus log base 9 of 7 to the 20th power. This then gives me log base 9 of 2 to the fifth times 3 to the fifth times 7 to the 20th. It is not the only option. After all, you'll notice that there's an 81 times 3 in here. And 81 is really 9 squared, which means that I could call this log base 9 of, let's see, that could give me, well, I would end up having a sum here. So I would have this 2 to the fifth times 3 times 7 to the 20th, and then I would have a plus 2 outside. So I broke that 4, and I now have a 2 outside, but that really doesn't help me much. So this would be my answer that I would be looking for, and I'm just showing you that we could get a different answer. Let's take a look at now expanding again. This time, log base 9 cubed root of a times b times c. Now in this problem, we have that 1/3 moving to the front, or I have to distribute it. This would then give me 1/3 log base 9 of a plus 1/3 log base 9 of b plus 1/3 of log base 9 of c. That would be my answer. Now I could call it 1/3 and put it as log base 9 of a over 3 plus log base 9 of b over 3 plus log base 9 of c over 3. Beware, they're the same answer. Let's take a look at the next one. Log base 9 of a to the 5th times b, the quantity squared. Once again, decide whether you're going to distribute at the beginning or whether you're going to distribute at the end. I'm going to go ahead and do it at the beginning this time, since I distributed at the end in the previous problem. This is then going to give me a to the 10th, b squared, and now I have 10 log base 9 of a plus 2 log base 9 of b. Last problem before we go to our last section. Natural log x, y to the 5th, the quantity is squared. Notice that the log itself is not getting in the way of this. We're still following in the same pattern that we did before. And our answers generally start to come in pretty quickly. Alrighty, let's go ahead and take a look at the last section. And once again, we are condensing into a single log in this one. So we have this log base 9 of a divided by 2 plus log base 9, log base 9 of b divided by 2 plus log base 9 of c divided by 2 plus log base 9 of d divided by 2. I'm going to factor out the 1/2, and because they are all log base 9 and they don't have any additional powers, I have a times b times c times d, which I can then say is log base 9 for the square root of a times b times c times d. And this would be my answer. Then we have log base 2 of 11 plus 3 log base 2 of 6 plus 3 log base 2 of 7. The product is going to, the sum becomes products and the powers move behind. So I have log base 2 of 11 times 6 cubed times 7 cubed. This would be my answer, unless I wanted to expand it out fully by multiplying. And to do that, I hope I have a calculator. Let's go ahead and go to our last one. 2 log base 7 of 11 plus log base 7 of 3 plus, and then I have log base 7 of 10 over 3. Notice the base is still the same in each case. This is actually a hidden power. So we're looking at 2 log base 7 of 11 plus log base 7 of 3 plus 1/3 log base 7 of 10. Notice that made it a heck of a lot easier to work with. We now have log base 7, and we can put it all as 11 squared times 3 times 10 to the 1/3 power, and that's my answer. So this is expanding logarithms, working with our 3 properties that were given in the notes and that we worked with previously last week. I hope this has helped you. If it has, please remember to click like, and if you have suggestions, feel free to mark it and let me know. Thank you very much. Appreciate it, Hornets. I hope you have a very good and safe weekend. Take care, and please be safe. Good night. Cheers.